Distribution of sleep duration in a population usually looks something like this. Most people in the middle, while some people on the short end, while others on the extremely long end. Now, people at both of these ends usually suffer from comorbidities such as depression, obesity, and other health-related problems. But what if I told you there are some people that sleep considerably less than the average without suffering from any of these issues? Today, I'll be exploring familial natural short sleep and hypotheses about the nature of the condition. So, familial natural short sleep is defined by people sleeping from 4 to 6.5 hours a day without any of the normal side effects usually associated with sleep loss, such as drowsiness and lowered cognitive performance. Interestingly, they even show strengths such as increased resilience towards sleep loss, higher behavioral drive, and they tend to be high achievers. Now, the familial part of FNSS comes from the fact that it usually runs in select families. This is believed to be caused by rare genetic mutations, of which around 4 to 5 have been identified. For example, a mutation in the DEC2 gene, as we show here in the slide, normally inhibits the production of orexin. Now, in this mutated copy, this inhibition doesn't occur, and we see an increased amount of orexin, which is awake promoting compounds, which means that people sleep less. This is consistent with animal studies in which transgenic mice with the mutation have shown reduced sleep compared to wild type mice. Now, to explain the effects of FNSS, one hypothesis is that the condition leads to more efficient sleep in a shorter period of time. This is in line with the fact that FNSS does not seem to cause harmful side effects, usually, with sleep loss. Also, a study found that two mutations associated with FNSS slows the progression of Alzheimer's disease in affected mouse models. Researchers observe a slower accumulation of amyloid plaques and tau tangles in mice with the mutation, which are suspected causes of Alzheimer's disease. As there's an observed correlation between poor sleep and Alzheimer's, the fact that the FNSS mutations are protective might point towards these more efficient sleep mechanisms. A second hypothesis is that individuals with FNSS have higher behavioral drive, therefore, they're better at fighting off the urge to sleep, thus, sleep less. This would align well with anecdotal evidence regarding personality qualities of short sleepers, and it also explains some observed sleep data patterns. One of these patterns is that individuals with FNSS have higher EEG delta power. Now, broadly speaking, EEG, as you see on the left, is a way to graphically measure brain activity using electrodes. Now, as you see on the right, delta waves are one of these ranges of frequencies, and it's generally associated with deep sleep in the early parts of the night. These waves, among other things, can be a measure of how quote-unquote sleepy someone was prior to sleeping. Higher EEG delta power, measured by wave amplitude, is generally correlated with greater sleepiness, also known as homeostatic pressure. So this means that natural short sleepers may be sleeping less, not because they sleep more efficiently, but rather they're better at fighting off the urge to sleep. Now, there's still so many mysteries with familial natural short sleepers. I mean, if they're able to sleep less with no drawbacks, shouldn't we expect, from natural selection alone, that these mutations be more prevalent in the population? Maybe there's additional drawbacks that we're not aware of. Maybe a reduction in sleep past a certain point isn't really beneficial, evolutionary speaking. Now, nevertheless, our understanding of FNSS is useful in better understanding sleep processes in general and could pave the road for therapeutic treatments for conditions such as insomnia.